Welcome back. In today's video, I'm going to be finding the enthalpy, that means the change in enthalpy of some equation. But in this case, we're given a general equation, and the general equation has its own enthalpy, in which we're given 4a plus 8c plus 12d as the reactant, and 8f plus 16b as the product. And the enthalpy for this equation was change in H is equal to minus 22.4 kg. And we're now being asked to find the enthalpy of the following, which are displayed on the screen. But before I comment, I would like to tell you to stick with me to the end of this video. Come along with your jotter, your pen, or any writing materials you can, because you will need to jot it down while watching this video. And then don't also forget to try out this question before watching this video. That means you can pause this video, then try out the question and comment your answer in the comment section. Then you can now watch the video after that. And don't also forget to like this video and subscribe to this channel for more. Okay, I'll be looking out for you guys in the comment section. So if you have any questions, suggestion, comments, do it to make use of the comment section. I will be there. Okay, so let's start. So the first step is to write out the general expression, or the expression in which we're given the enthalpy change. Now, what we're trying to do is we're trying to relate each of those questions that we're given to find the enthalpy to the what? To the one in which we're given the enthalpy change. So once we're able to relate it, then we can now use that one to find the enthalpy. Now let's take, for example, now question 1. We have A is equal to 12A plus 24C plus 36D. Then the product is 24F plus 48B. Now, if you look at this expression very well, if you multiply 3 in the general equation, we're going to have what we're given as question A, right? So now, what this means is that the enthalpy change is going to be times 3 of the enthalpy in the general expression. So what we're now going to do is the enthalpy for the general expression will multiply by 3 to get our enthalpy for question A, which is going to give us minus 32.4 times 3, which is minus 97.2, and don't forget the unit kg, minus 97.2 kg. Now let's look at the next question, which is question B. Now question B is 2a plus 4c plus 6d, then the product is 4f plus 8b. Now let's try and equate this to the general expression, or to the expression in which we are given the change in enthalpy. Now if you look at the general expression, if we divide 2 by 2 or multiply by 1 over 2, we're going to get what we have in question B, which means that the enthalpy change for this expression is 1 over 2 of the enthalpy change for the general expression. Permit me to use the word general expression because we're trying to relate all the questions we're given to that expression, since we're given the enthalpy change for that expression. So what this means is the enthalpy change is the enthalpy change of that general equation over 2. So this is going to give us enthalpy change of B is equal to change in enthalpy times 1 over 2, which is the enthalpy change is equal to minus 32.4 times 1 over 2, which is change in enthalpy B is equal to minus 16.2 kg. Don't forget your unit and don't forget the minus sign. The minus sign has an importance in that question. Okay, now let's go to question C. Now, question C is 2f plus 4b, then the product is A plus 2c plus 3d. Now, if you look at this, the product of the general expression is the reactant of question C, and the reactant of the general expression is now the product of question C. That means the first thing we need to notice is that the sign of the enthalpy is going to change. Since the one for the general expression is minus 32.4 kg, then the one for question C, before we can be able to find if for this general expression for question C is change in enthalpy is equal to 32.4 kg, since it's the reverse of the general expression. Now, if you now look at this very well, if you divide the general expression, the reverse of the general expression, by 4, we are going to have what is the question of question C. Or if you multiply by 1 over 4, we are going to have the expression of what is in question C. So now this can now be written as what? Change in enthalpy for question C is equal to what? Change in enthalpy of the general expression times what? 1/4. Okay? Then you start the general enthalpy value. Get 2.4 for this question times what? 1/4 since it's the reversal. So this is going to give us what? 8.1 kg. Note there's no minus sign in this question because what? We are considering the reverse of the what? General expression, unlike the rest. Let's look at question D. So question D is what? 40F plus what? 80B, then 20A plus 40C plus 60D. Now this is also the reverse of the general expression, but not really exactly the reverse. It's just like the product of the general expression is the reactant, and the reactant of the general expression is the product times something. Now look at this and look at the general expression. If you multiply the reverse of the general expression by 5, you're going to get what is here. So now the enthalpy change for this expression is now what? The enthalpy change for question D is equal to what? The change in enthalpy times 5. That is what? 32.4 times what? Times 5. That is going to give us what? Comment the answer in the comment section. Let's see who watched the video to the end. If you know you watched this video or this tutorial class to this point, do well to comment your solution or your answer in the comment section. I'll be there. So I've come to the end of today's class. Thank you for watching. Do well to click the subscribe button, the like button, and don't also forget to share this video to your friend, your classmate, even your enemies that deserve to watch this video. Do well to share this video to them, and don't also forget to comment your thoughts, your questions, and anything at all you want UG tutorial to be aware of in the comment section, or you can message us privately. Always available. See you in our next class. Bye for now.